You know, ever since the first incredible images from the James Webb Space Telescope started beaming back to Earth, the internet has just been on fire. There's this amazing excitement that maybe, just maybe, it's already found what we've all been hoping for. But the rumors have gotten a little wild. I mean, just look at this. This comment pretty much sums up the entire vibe online. We're talking Dyson spheres, actual city lights on other planets, even objects headed our way. It's straight out of science fiction, right? And a lot of people are seriously wondering if it's finally become science fact. So what is the real story here? Well, that's exactly what we're going to get into. We're going to peel back all those layers of internet hype and crazy rumors to get to the actual and honestly even more mind-blowing science of what the JWST is really doing in its search for life. Okay, so first things first. Before we can even talk about exoplanets and aliens, we have to talk about how these wild stories get started in the first place. Learning how to tell the difference between real science and, sensational clickbait is probably one of the most important skills you can have these days. And this is a perfect example of the problem. On the left, you've got this headline just screaming, 100% cure. It's a massive, definite claim. But then you look at the reality on the right. It was a small study, it wasn't well controlled. See how the more responsible headline adds those crucial warnings? That huge gap between the headline and the real science, that's where all the misinformation lives. The good news is, you can totally spot this stuff. Next time you see some crazy science headline, just run through this little checklist. Is the headline over the top? Who are the sources? Is it an actual peer-reviewed study or just a draft? Do they quote real experts? And maybe most important of all, look for the caveats. Real science is almost never 100% certain. And honestly, this comment just nails it. When we see somebody claiming JWST found aliens, the very first question has to be, okay, show me the data. The source can't just be, trust me, bro, or, a cat. Real science demands real, verifiable evidence, not just whispers on the internet. All right, now that we're all on the same page, let's get into the actual science. And the first thing to understand is why it's so ridiculously hard to even see a planet around another star. The scale of this challenge is just hard to wrap your head around. People always use this analogy, and for good reason. It's perfect. Trying to spot an Earth-like planet next to its star is like standing miles away and trying to see a single tiny firefly that's hovering right next to a giant, blindingly bright searchlight. The star's glare just completely erases the planet. Just look at that number, 10 billion to 1. That's how much brighter our sun is than the Earth. That is the insane fundamental problem that astronomers have to somehow overcome. So how in the world do they do it? With an amazingly clever bit of science called coronagraphy. Basically, it's like creating a tiny, perfect eclipse right inside the telescope. They use a special mask to block the light from the star itself, which suddenly makes the super faint light of an orbiting planet visible. It's ingenious. And one of the wildest ideas for how to do this is something called a star shade. Now, this isn't just a little mask inside the telescope. No, this is a whole separate spacecraft shaped like a giant metal flower that would fly tens of thousands of kilometers away from the telescope. It has to position itself with insane precision to block the starlight before it even gets there. The engineering behind that idea is just wow. Okay, so we figured out how Webb can beat the glare and actually see a planet. But that's just step one. The real mission, the Holy Grail, isn't just finding a dot. It's figuring out what's in that planet's atmosphere. And that brings us to this incredibly important idea: biosignatures. Now, we're not talking about city lights or alien structures. We're talking about chemical fingerprints. We're looking for specific gases in an atmosphere that are really hard to explain with just geology or chemistry. Gases that strongly hint that something biological is making them. So how does this chemical detective work happen? Well, as a planet passes in front of its star, that's called a transit, some of the starlight shines right through the edge of its atmosphere. Now, the gases in that atmosphere are picky. They absorb very specific colors of light. Webb is so sensitive, it can analyze the light that gets through, see which colors are missing, and that tells us exactly what gases are in that atmosphere. It's amazing. And here are a few of the top suspects on the most wanted list. You've got oxygen and ozone, which on Earth are overwhelmingly from photosynthesis. You've got methane, another huge byproduct of life here. Even something like nitrous oxide could be a sign of bacteria. Finding any of these would be huge. Finding them together, that would be a game changer. And check this out. This is where it all clicks. On the left, you can see the unique barcode of light that different molecules absorb. And on the right, that's the actual light from our own planet Earth. You can see the fingerprints of oxygen, water, and ozone clear as day. Our own biosphere is screaming its existence into space. That is exactly what we're trying to find on another world. But what if we took it a step further? What if we found not just a biosignature, but a technosignature? I'm talking about signs of technology. Webb is so powerful that it might even be able to detect certain industrial pollutants, like CFCs. Why is that a big deal? Because as far as we know, there are no natural processes that make them. Finding CFCs would be a smoking gun for an industrial civilization. Now, this all sounds incredibly cool, and believe me, it is. But it's also important to be realistic. Science is all about understanding the challenges, and when it comes to finding life, not all planets are created equal. Some of the most common ones out there come with some pretty serious problems. Let's take red dwarfs, for example. They are by far the most common stars in our galaxy, and they live for trillions of years. That's a huge plus, right? Tons of time for life to get going. But here's the catch. Planets orbiting them get tidally locked, meaning one side is eternally scorched and the other is frozen solid. Oh, and these stars throw off violent solar flares that could just blast a planet's atmosphere right off into space. So it's complicated. And then there's this other nagging question. What if we find something that looks like a sign of life, but it's not? A false positive? Could a totally dead planet create oxygen through some weird non-biological chemical reaction? It's something scientists are working really hard to figure out so we don't get tricked. But you know, the false negative problem might be even bigger. Just look at our own planet's history. Life existed on Earth for billions of years before enough oxygen built up in the atmosphere to be seen from far away. For most of its history, Earth was alive, but its biosignature was totally invisible. That could mean that life is everywhere, but detectable life is incredibly rare. So after all that, what does this really mean for the search for aliens? What would that moment of first contact actually look like? It's time we all kind of redefine what we're expecting. And here's the bottom line. The real search for life isn't about spaceships or weird radio signals. It's slow, careful, methodical detective work. It's about using an instrument of unbelievable power to catch a few photons of light and piece together the chemical story of an atmosphere trillions and trillions of miles away. In the end, the first proof of alien life probably won't be some big dramatic announcement. It might not be a message at all. It might just be a little dip in a line on a graph. The quiet, unmistakable fingerprint of a single molecule in a beam of light from a distant star. It's a discovery that would be so quiet, yet have the loudest implications imaginable. The only question left is, are we ready to find it?
Welcome to The Deep Dive. We take the sources, we dig in, and we bring you the key insights. Today, we're heading out into the cosmos. We're talking exoplanets and that really big question, are we alone? It feels like a huge scientific detective story is playing out, especially with the James Webb Space Telescope feeding us these, well, unprecedented clues.
That's absolutely right. And our goal today really is to sift through all the chatter. What can observatories like JWST actually tell us? And what are the real scientific methods we're using in this search for life?
Yeah, because you see a lot online, don't you? Claims about Webb spotting, quote, non-natural objects, or maybe even these giant Dyson spheres. Sometimes even talk of non-human intelligence radio signals. And you definitely hear whispers about, classified briefings, NASA hiding things.
Right, and it's so important to, approach those kinds of claims very skeptically. Honestly, they just lack credible scientific backing. NASA's been quite explicit. They've denied any classified briefings about stuff like that. It's a classic sign, Sensational headlines, no solid sources, big red flags in science reporting. And fundamentally, JWST sees in infrared light. It's built to detect heat, chemical signatures in atmospheres. It's just not designed to visually spot alien ships or pick out city lights. That's not its job.
Okay, that's a really key point. So if it's not looking for UFOs, what is its superpower? What's the actual tangible evidence it's providing for this search?
Its real strength, its breakthrough capability, is analyzing the chemistry of exoplanet atmospheres directly. We've moved past just finding planets. Now we're starting to characterize them. It's amazing, really. We've already seen it detect water vapor on gas giants like WASP-D 96b, and it pinpointed carbon dioxide, even sulfur dioxide on WASP-P 39b. That points strongly towards photochemistry, chemical reactions powered by starlight.
Photochemistry, right.
Yeah, and it's found methane and CO2 on K218b, maybe even hints of water on rocky worlds like GJ486b. Plus, it measures temperatures like the dayside heat on planets near TRAPPIST-1, helping us narrow down what their atmospheres could be made of. It's vital data.
Okay, so you get this atmospheric data. Then what? How do scientists take that leap to looking for actual life? What are the signs?
We're looking for things called biosignatures, basically detectable clues that life might be present in the atmosphere. That could be gases like oxygen, ozone, methane, nitrous oxide, even certain industrial pollutants like CFCs, which are, very rarely made naturally. Those could be a sign. Or on the surface, maybe something like the vegetation red edge, a specific light signature from chlorophyll or similar pigments.
Wow, but couldn't planets just make these gases naturally? How do you avoid false positives? That seems like a huge hurdle.
It absolutely is. That's the core challenge, telling biological sources apart from just, geology or atmospheric chemistry. The key isn't usually finding just one gas, it's about the combination. Finding gases together that shouldn't really coexist in large amounts without something constantly producing them, like oxygen and methane. That state is called chemical disequilibrium. That's hard to explain without biology constantly replenishing them. So confirming life likely needs multiple lines of evidence observed across a wide spectrum UV, visible light, infrared, and in high detail, not just one little blip. And just seeing these planets is tough. Direct imaging is incredibly hard. Think about trying to spot a tiny firefly right next to a blindingly bright searchlight from miles off. So we need really clever tech. Things like coronagraphs, they physically block the star's light, or interferometers combining light from multiple telescopes to get super sharp views. That's how we might eventually resolve these faint little worlds. And where do we point these amazing instruments? Well, red dwarf stars like Proxima Centauri are actually top targets.
Really? Even with things like flares and being tidally locked?
Yeah, despite those challenges, they're just so common. And they live for trillions of years, potentially giving life much, much longer to get started and evolve than around stars like our sun. Look, this whole search, it's incredibly complex. It needs patience. It needs seriously advanced technology. But what if we do all this, put in all this effort, and we don't find that definitive smoking gun, that biosignature?
Right. What does that mean? I guess you have to consider Earth, right? For billions of years, life was here, but it wasn't pumping out oxygen we could detect from afar. It's such a powerful reminder, isn't it? Just because we don't see the evidence doesn't automatically mean nothing's there. This whole journey, it seems less about a quick yes or no and more about understanding the universe and, well, our place in it all. Feels like we're really just at the beginning. It's definitely a marathon, not a sprint. So, what really stands out to you from all this? We hope you keep exploring this amazing frontier with us.